By 2100, our ability to detect and analyze exoplanets will have undergone a revolution, transforming our understanding of the universe. We can envision space telescopes far more powerful than anything we have today, equipped with cutting-edge technology and innovative designs. These instruments will be capable of directly imaging exoplanets and even analyzing their atmospheres for signs of life, providing unprecedented insights into distant worlds. Imagine telescopes with mirrors spanning hundreds of meters deployed in space to eliminate atmospheric distortion, capturing the faintest glimmers of light from far-off planets. These behemoths will capture light from distant worlds with unprecedented clarity, allowing us to study their surfaces, weather patterns, and even seasonal changes. Spectroscopy, the technique of analyzing light's interaction with matter, will become even more sophisticated, enabling us to decode the secrets of exoplanetary atmospheres. We will be able to identify the chemical fingerprints of water, methane, oxygen, the potential signatures of life, in the atmospheres of exoplanets light-years away, opening new avenues in the search for extraterrestrial life. But our search won't be limited to light. It will encompass a variety of detection methods. We'll also develop advanced techniques to detect gravitational waves, ripples in space-time caused by the acceleration of massive objects, offering a new dimension to our observations. These waves can reveal the presence of planets orbiting pulsars, the rapidly rotating remnants of dead stars, and even black holes, providing insights into the most extreme environments in the universe. Artificial intelligence will play a crucial role in managing and analyzing the vast amounts of data collected by these instruments, ensuring that no detail goes unnoticed. Sophisticated algorithms will sift through the cosmic noise, identifying promising exoplanet candidates and flagging intriguing anomalies for further investigation, accelerating our pace of discovery. This combination of advanced telescopes, sensitive instruments, and powerful computing will usher in a golden age of exoplanet discovery, transforming our understanding of the cosmos. We'll go from detecting their presence to understanding their nature, their history, and perhaps even their potential for harboring life, bringing us closer to answering the age-old question, are we alone in the universe? Humanity's yearning to explore knows no bounds. While robotic missions will remain invaluable tools for scientific exploration, the dream of sending humans to other star systems will continue to inspire us. By 2100, we may have made significant strides towards achieving interstellar travel, though the challenges are formidable. The vast distances between stars are daunting, even for the most optimistic projections of technological advancement. Traditional chemical rockets, while reliable, are simply too slow for interstellar voyages. We'll need revolutionary propulsion systems that can achieve speeds approaching the speed of light. One possibility lies in harnessing the power of fusion, the same process that fuels the stars. Fusion rockets, theoretically capable of achieving a significant fraction of the speed of light, would dramatically reduce travel times to nearby star systems. Another intriguing concept is the Alcubierre drive, a theoretical warp drive that manipulates space-time to create a bubble around a spacecraft, effectively allowing it to travel faster than light. While still in the realm of science fiction, the Alcubierre drive demonstrates the kind of outside-the-box thinking needed for interstellar travel. Even if we overcome the technological hurdles, the ethical and logistical challenges of sending humans across such vast distances are immense. Generational ships, self-sustaining arcs carrying entire communities on journeys spanning centuries, present profound questions about human nature and the nature of society. Section 4. Finding Earth 2.0. The discovery of a truly Earth-like exoplanet, a world with oceans, continents, and a breathable atmosphere, would be a watershed moment in human history. Such a discovery would not only expand our understanding of the universe but also ignite our imagination about the possibilities of life beyond Earth. By the year 2100, we may have identified numerous candidates, but confirming their habitability will require meticulous observation and analysis. Scientists will need to scrutinize every detail, from the planet's distance to its star, to the chemical composition of its atmosphere. Advanced telescopes will allow us to study the atmospheres of these distant worlds in unprecedented detail, searching for biosignatures, gases like oxygen, methane, and ozone that are indicative of life as we know it. These instruments will be our eyes in the cosmos, revealing secrets hidden light-years away. We'll also look for evidence of liquid water, a fundamental ingredient for life as we understand it. The presence of water in any form, whether in vast oceans or small lakes, would be a promising sign. The presence of oceans, lakes, or rivers would greatly increase the likelihood of a planet's habitability. These bodies of water could serve as cradles for life, just as they did on Earth billions of years ago. However, even the most Earth-like exoplanet may present challenges to human colonization. The journey to these distant worlds would be fraught with unknowns, and the conditions we find there might be harsh and unforgiving. The atmosphere might contain unknown toxins, the gravity could be significantly different, and the planet's magnetic field may not be strong enough to shield us from harmful radiation. These factors could pose serious risks to human health and survival. Before we can even contemplate sending humans to these distant worlds, we'll need to develop advanced technologies for terraforming, altering a planet's environment to make it more suitable for human life. This could be one of the greatest engineering challenges humanity has ever faced. This process could involve introducing Earth-based organisms to create a breathable atmosphere, manipulating a planet's albedo to regulate its temperature, or even engineering entirely new life forms adapted to the specific conditions of the exoplanet. Each step would require careful planning and execution. Finding Earth 2.0 will require not only scientific prowess but also a deep understanding of planetary ecosystems and the complex interplay of life and the environment. It will be a monumental task, but one that could ultimately lead us to new horizons and a greater appreciation of our place in the universe. Section 5. The Ethics of Cosmic Expansion. The prospect of colonizing other worlds raises profound ethical questions that challenge our very understanding of morality and responsibility. Do we have the right to claim ownership of planets beyond our own? And what does ownership even mean in the vast expanse of space? What are our obligations to any indigenous life forms we might encounter? And how do we ensure their protection and respect their autonomy? These are questions that humanity has grappled with for centuries, often with mixed results and significant consequences. But they take on a new urgency in the context of interstellar exploration, where the stakes are higher and the unknowns are greater. The history of colonialism on Earth is a cautionary tale, filled with lessons that we must heed as we look to the stars. It is rife with exploitation, violence, and the destruction of cultures, often justified by a sense of superiority and entitlement. As we venture into the cosmos, we must learn from our past mistakes and approach other worlds with humility, respect, and a commitment to peaceful coexistence. This means recognizing the intrinsic value of all life forms and ecosystems and striving to protect them from harm. One guiding principle could be the concept of planetary protection, ensuring that we do not contaminate other worlds with Earth-based life or vice versa. This would involve rigorous sterilization procedures for spacecraft and equipment, as well as strict protocols for human activities on other planets. These measures are essential to prevent the unintended spread of microorganisms that could disrupt alien ecosystems or pose a threat to human health. Additionally, careful monitoring of any interactions between humans and extraterrestrial ecosystems is crucial to ensure that we do not cause irreversible damage. Another consideration is the potential impact on future generations, who will inherit the consequences of our actions today. Our decisions today will shape the course of human civilization for centuries to come, influencing the way we live, interact, and explore the universe. We must ensure that our actions are guided by a long-term vision that prioritizes the well-being of both humanity and the universe we inhabit. This vision should encompass not only technological advancements but also ethical considerations that respect the rights and dignity of all beings. The ethics of cosmic expansion are complex and multifaceted, with no easy answers, but they are essential to our future. By engaging in thoughtful dialogue and embracing a spirit of cooperation, we can navigate these challenges together. We can strive to create a future where humanity's presence among the stars is a force for good, fostering peace, understanding, and mutual respect across the cosmos of supernovae, each event a testament to the dynamic and ever-changing nature of the cosmos. The search for another Earth is just one of many journeys that await us. Each mission, each discovery, brings us one step closer to understanding the vast expanse of space. It is a journey that could lead us to the answer to one of humanity's oldest questions. Are we alone? The quest for another Earth is not just about finding a new home, but about finding our place in the universe. The search for another Earth is challenging. It is difficult to detect planets around other stars. They are small and faint compared to their host stars. The distances involved are immense. Even the closest stars are trillions of miles away. Our current technology is limited. We are only beginning to develop the tools needed to find Earth-like planets. Another factor is time. Planets take a long time to form and evolve. Life may take even longer to emerge. We may need to observe a star system for centuries or even millennia to detect signs of life. Despite these challenges, we are making progress. Scientists are developing new technologies and techniques to aid in the search. The discovery of another Earth is only a matter of time. Scientists use several methods to discover exoplanets. The transit method is one of the most successful. It looks for dips in a star's brightness caused by a planet passing in front of it. Another method is the radial velocity method, also known as the Doppler spectroscopy method. It looks for wobbles in a star's movement caused by the gravitational pull of an orbiting planet. These methods have allowed us to detect thousands of exoplanets. However, most of these planets are gas giants or ice giants, not suitable for life as we know it. Finding smaller, Earth-sized planets is much more difficult, but new telescopes and instruments are being developed to increase our chances of success. By 2110, our technology will have advanced significantly, reaching levels we can only dream of today. The pace of innovation will be unprecedented, transforming our understanding of the universe. We can expect to see telescopes far more powerful than anything we have today, capable of peering deeper into space and revealing secrets hidden in the farthest corners of the cosmos. These telescopes will be equipped with advanced adaptive optics, a technology that will revolutionize our ability to observe the universe. Adaptive optics will allow us to correct distortions in real time, providing crystal clear images. They will be able to cancel out the blurring effects of Earth's atmosphere, which has long been a challenge for astronomers. This will enable us to see celestial objects with unprecedented clarity. Space-based telescopes will be even more powerful, as they will operate above the Earth's atmosphere, free from any interference. This will allow them to capture images that are impossible to obtain from the ground. They will be free from atmospheric interference, providing a clear and unobstructed view of the universe. This will open up new possibilities for discovery and exploration. These telescopes will be able to detect the faintest signals from distant worlds, picking up light that has traveled across the vast expanse of space. This will help us identify planets orbiting other stars. Artificial intelligence and machine learning will also play a key role in exoplanet discovery. These technologies will assist scientists in processing and analyzing the enormous amounts of data collected by telescopes. These technologies will be able to analyze vast amounts of data, sifting through it to find patterns and signals that might indicate the presence of exoplanets. This will greatly enhance our ability to discover new worlds. They will be able to identify potential exoplanets that might have been missed by human observers, ensuring that no stone is left unturned in our search for other Earth-like planets. These advancements will usher in a new era of discovery, one where the boundaries of our knowledge are constantly being pushed further. The excitement and potential for new findings will be limitless. We will be able to find and characterize exoplanets in unprecedented detail, learning about their atmospheres, compositions, and potential for supporting life. This will bring us closer to answering the age-old question, are we alone in the universe? We will be closer than ever to finding another Earth, a planet that could potentially harbor life. This new era of discovery will transform our understanding of the cosmos and our place within it. Section 5. Bridging the Cosmic Gulf. The challenge of interstellar travel. Finding a potentially habitable exoplanet is only the first step. The next challenge is reaching it. The distances involved are staggering. Even traveling at the speed of light, it would take years to reach the nearest stars. Conventional propulsion systems such as chemical rockets are not practical for interstellar travel. They require enormous amounts of fuel. This makes them too slow and expensive for such journeys. Scientists are exploring new propulsion technologies for interstellar travel. These include fusion rockets, antimatter propulsion, and warp drives. These technologies are still theoretical, but they offer the potential for faster-than-light travel. Overcoming the challenges of interstellar travel will require breakthroughs in physics and engineering. But the dream of reaching the stars continues to inspire us. It drives us to push the boundaries of what is possible. Section 7. Are we alone? The search for extraterrestrial life. The discovery of a habitable exoplanet would inevitably raise the question, does it harbor life? The search for extraterrestrial life is one of the most profound scientific endeavors of our time. Scientists are developing new technologies to search for signs of life on exoplanets. These technologies will analyze the atmospheres of exoplanets for biosignatures. Biosignatures are chemical compounds that could indicate the presence of life. The discovery of extraterrestrial life would have a profound impact on our understanding of the universe and our place in it. It would answer one of humanity's oldest questions: are we alone? The search for extraterrestrial life is a search for ourselves. It is a search for our place in the cosmos. It is a search that could change our understanding of the universe forever. Place in the cosmos. The search for another Earth and for extraterrestrial life are ultimately about understanding our place in the cosmos. They are about answering the fundamental questions that have haunted humanity for millennia. Where did we come from? Are we alone? What is our destiny? Space exploration is a journey of self-discovery. It is a journey that takes us beyond the confines of our planet and forces us to confront the vastness and mystery of the universe. As we continue to explore the cosmos, we are filled with a sense of awe and wonder. We are reminded of the preciousness of life and the importance of preserving our own planet. The universe is calling. Let us answer with courage, curiosity, and a deep sense of hope. The night sky is full of stars. Each one twinkles with a light that has traveled across the vast expanse of space to reach us. When we look up, we are not just seeing points of light, we are witnessing the history of the universe. Each star is a sun, possibly with planets of its own. These planets, known as exoplanets, orbit their stars just as the Earth orbits the sun. Some of these exoplanets are in the habitable zone, where conditions might be just right for life to exist. Could some of these planets be like Earth? Could they have life? Scientists are particularly interested in finding Earth-like planets because they might have the right conditions for liquid water, an essential ingredient for life as we know it. The universe is vast and full of mysteries. Our Milky Way galaxy alone contains billions of stars, and beyond that, there are billions of other galaxies, each with its own stars and planets. The sheer scale of the universe is mind-boggling. The search for life beyond Earth is one of the most exciting adventures in science. Scientists use powerful telescopes and space probes to explore distant planets and gather data. They analyze this data to look for signs of life, such as the presence of water, an atmosphere, or other biosignatures. For centuries, humans have wondered if we are alone in the universe. Ancient civilizations looked to the stars and imagined gods and otherworldly beings. In more recent times, astronomers have used telescopes to search for planets and signs of life. Now we are closer than ever to finding out. Advances in technology have given us tools that previous generations could only dream of. Modern observatories and space missions are providing us with detailed images and data from distant worlds. New telescopes and spacecraft are giving us an unprecedented view of the cosmos. Instruments like the Hubble Space Telescope and the upcoming James Webb Space Telescope allow us to peer deeper into space and time than ever before. We are discovering new planets all the time. Each discovery brings us one step closer to finding a planet that might host life. Scientists catalog these exoplanets and study their characteristics to determine their potential habitability. Some of these planets might be capable of supporting life. They might have the right conditions for liquid water, a stable climate, and the right chemical ingredients. The discovery of such a planet would be a monumental step in answering the age-old question: are we alone in the universe? As we continue our search, we must also consider what form this life might take. It could be microbial, similar to the earliest forms of life on Earth, or it could be more complex. The possibilities are endless and fuel our imagination and scientific curiosity. We are also sending signals into space, hoping that if there is intelligent life out there, they might respond. Projects like SETI, Search for Extraterrestrial Intelligence, are dedicated to listening for signals from other civilizations. The search for extraterrestrial life is a collaborative effort that spans the globe. Scientists from different countries and disciplines work together, sharing data and ideas. This global effort brings humanity closer together in our quest to understand our place in the universe. The question of whether we are alone in the universe is not just a scientific one, it is a deeply human one. It speaks to our curiosity, our desire to explore, and our need to understand our place in the cosmos. As we look up at the night sky, we are reminded of the endless possibilities that await us. the journey to find life beyond Earth is just beginning. With each new discovery, we take another step on this incredible adventure. Whether we find life or not, the search itself is a testament to the human spirit and our unending quest for knowledge. The answer to the question, "Are we alone?" may still be out there, waiting to be discovered. Until then, we will continue to explore, to search, and to dream. The night sky is full of stars. Planets that orbit other stars are called exoplanets. These fascinating celestial bodies have captured the imagination of scientists and space enthusiasts alike. They offer a glimpse into the vast diversity of planetary systems that exist beyond our own solar system. These planets come in all shapes and sizes. Some are massive gas giants, while others are small and rocky. The variety is truly astounding, with some exoplanets even having unique characteristics that we don't see in our own solar system. Some are giant gas planets like Jupiter. These colossal worlds are composed mainly of hydrogen and helium, and they often have multiple moons orbiting them. Their thick atmospheres can create stunning visual phenomena such as swirling storms and colorful cloud bands. Others are small and rocky like Earth. These terrestrial planets may have solid surfaces and could potentially harbor life. Scientists are particularly interested in finding Earth-like exoplanets in the habitable zone, where conditions might be right for liquid water to exist. Scientists have discovered thousands of exoplanets. Each new discovery adds to our understanding of the universe and the potential for life beyond Earth. The search for exoplanets is one of the most exciting and rapidly advancing fields in astronomy today. They use many different methods to find them. Some of the most common techniques include the transit method, where scientists look for a dip in a star's brightness as a planet passes in front of it, and the radial velocity method, which measures the star's wobble caused by the gravitational pull of an orbiting planet. One way to find exoplanets is to look for a star that wobbles. This wobble occurs because the planet's gravity exerts a small but detectable force on the star, causing it to move in a tiny orbit of its own. A star with a planet orbiting it will move slightly back and forth. This motion can be incredibly subtle, but with precise instruments, astronomers can measure these tiny shifts in the star's position. This is because the planet's gravity tugs on the star. The gravitational interaction between the star and its planet creates a dance of sorts, with both bodies moving in response to each other's presence. By measuring the wobble of a star, scientists can detect the presence of a planet. This method has been instrumental in discovering many of the exoplanets we know today, providing valuable insights into the nature and diversity of planetary systems throughout the galaxy. Another way to find exoplanets is to look for a star that dims slightly. If a planet passes in front of a star, it will block a tiny bit of the star's light. This is called a transit. By measuring the dip in a star's brightness, scientists can learn about the size and orbit of the planet. Finding exoplanets is a challenging task, but scientists are developing new and better ways to find them. As we learn more about exoplanets, we get closer to answering the question, are we alone? Not all exoplanets are created equal. Some are too hot or too cold for life, others are gas giants with no solid surface, but some exoplanets might be just right for life as we know it. These planets are called habitable zones. A habitable zone is the region around a star where temperatures are just right for liquid water to exist on the surface of a planet. Water is essential for life as we know it. So finding a planet in the habitable zone is a big step towards finding life beyond Earth. Section 5. Journeys to the Stars. The dream of traveling to the stars has captivated humanity for generations. From ancient stargazers to modern scientists, the allure of the cosmos has always been a source of wonder and inspiration. Traveling to even the nearest stars is a daunting challenge. The vastness of space is almost beyond comprehension. The nearest star system, Alpha Centauri, is over 4 light-years away. This means that even at the speed of light, it would take over 4 years to get there. The distances are incredibly vast. To put it into perspective, our fastest spacecraft, Voyager 1, which has been traveling for over 40 years, has only just reached the edge of our solar system. It would take tens of thousands of years for it to reach the nearest star. Traditional rockets would take tens of thousands of years to reach even the closest star system. This is because they rely on chemical propulsion, which is not efficient enough for interstellar travel. The energy required to reach such distant destinations is far beyond what our current technology can provide. But scientists are exploring new technologies that could make interstellar travel possible. Advances in physics and engineering are opening up new possibilities. Concepts that were once considered science fiction are now being seriously studied and developed. One possibility is fusion propulsion. Fusion propulsion involves using the same process that powers the stars to propel a spacecraft. This process, known as nuclear fusion, involves fusing atomic nuclei to release energy. Fusion is the process that powers the stars. In the core of stars, hydrogen atoms fuse together to form helium, releasing enormous amounts of energy in the process. This energy is what makes stars shine so brightly. It releases enormous amounts of energy. If we could harness this energy for propulsion, it could revolutionize space travel. Fusion rockets could potentially provide the high speeds needed for interstellar travel. A fusion rocket could potentially reach speeds of a significant fraction of the speed of light. This would make it possible to travel to nearby stars within a human lifetime. Instead of taking tens of thousands of years, the journey could be reduced to just a few decades or even years. This would cut down travel times to nearby stars to decades or even years. The dream of interstellar travel is still a long way off, but with continued research and development, it may one day become a reality. The stars may not be as out of reach as they once seemed. Section 6. Is there life out there? Finding evidence of life on another planet would be one of the most profound discoveries in human history. It would change our understanding of our place in the universe. But how would we know if we found life? Scientists are looking for biosignatures. These are chemical compounds or patterns that could only be produced by life. For example, oxygen in a planet's atmosphere could be a sign of photosynthesis. Methane could be a sign of microbial life. Section 7. New homes among the stars. As Earth's resources dwindle and our environment changes, some scientists believe that humanity's future may lie among the stars. Colonizing other planets could give us a second chance to build a sustainable future. Terraforming is the process of transforming a planet to make it more Earth-like. This could involve changing the atmosphere, temperature, or surface of a planet. While terraforming is still in the realm of science fiction, it could become a reality in the distant future. Section 8. The universe awaits. The discovery of exoplanets has opened up a new chapter in human exploration. For the first time, we know for sure that there are other worlds out there. Some of these worlds might be like our own. Others might be stranger than we can imagine. The universe is vast and full of possibilities. As we continue to explore, we are sure to make new and amazing discoveries. The future of humanity may lie among the stars. Section 9. A cosmic perspective. The search for life beyond Earth forces us to confront some profound questions. What does it mean to be human? What is our place in the universe? Are we alone? These are questions that have no easy answers. But one thing is certain, the more we learn about the universe, the more we realize how much we don't know. The universe is a place of wonder and mystery, and we are just beginning to explore. The cosmic question. Is there life beyond Earth? This question has intrigued scientists, philosophers, and dreamers alike for generations. It's a question that has captivated humanity for centuries. From ancient astronomers who charted the stars to modern scientists who probe the depths of space, the quest to find life beyond our planet has been a constant pursuit. The vastness of space hints at endless possibilities. With billions of stars in our galaxy alone, the potential for other worlds is staggering. Could some of those twinkling stars harbor planets like our own? Planets that might have the right conditions to support life? Could those planets be teeming with life? Life that might be similar to us, or perhaps entirely different, shaped by the unique conditions of their home worlds? For a long time, the idea of finding life on other planets was confined to the realm of science fiction. Stories of alien civilizations and interstellar travel filled our imaginations. But now, the search for extraterrestrial life is a scientific reality. Advances in technology have made it possible to explore the cosmos in ways that were once thought impossible. We are actively searching for signs of life beyond Earth, and the quest is more exciting than ever before. Scientists are using powerful telescopes and sophisticated instruments to scan the skies for signals and signs of life. The possibility of one day colonizing other planets is no longer a far-fetched dream. With each new discovery, we move closer to the day when humans might live on other worlds. It's a potential future that is within our reach. The advancements in space travel and technology are paving the way for humanity to become an interplanetary species. The journey begins with understanding the cosmos and searching for planets that could support life as we know it. This involves studying the atmospheres, climates, and potential biosignatures of distant worlds. Our galaxy, the Milky Way, is a vast cosmic city of billions of stars. Each star is a potential sun to its own system of planets, and within this city, there are likely billions of planets. Some of these planets may be rocky like Earth, while others could be gas giants or icy worlds. Some of these planets may be similar to Earth, orbiting their stars in the habitable zone where temperatures are just right for liquid water to exist. This Goldilocks zone is crucial for the potential of life. The search for these exoplanets is one of the most exciting areas of modern astronomy. With each new discovery, we learn more about the potential for life beyond our own planet. The Drake equation, formulated by Dr. Frank Drake, attempts to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. It considers factors like the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life. Organizations like SETI, the Search for Extraterrestrial Intelligence, are dedicated to listening for signals from other civilizations. They use radio telescopes to scan the sky for any signs of intelligent life. The discovery of even a single signal from an alien civilization would be one of the most profound events in human history. It would forever change our understanding of our place in the universe. As we continue to explore the cosmos, we are not just searching for life, we are also expanding our own horizons. Each mission, each discovery, brings us closer to understanding the universe and our place within it. Whether we are alone in the universe or not, the search itself is a testament to our curiosity and our desire to reach beyond the known. It is a journey that defines us as a species. For centuries, the idea of planets orbiting other stars was pure speculation. The night sky filled with countless stars was a source of wonder and mystery. Ancient civilizations gazed up, creating myths and legends about the celestial bodies they saw. They imagined gods, heroes, and monsters inhabiting the heavens, but the notion of other worlds like our own remained a distant dream. Ancient philosophers pondered the existence of other worlds, but it wasn't until the 20th century that we had the tools to detect them. The invention of the telescope in the early 1600s marked the beginning of a new era in astronomy. With each advancement in technology, our understanding of the universe expanded. By the 20th century, we had developed sophisticated instruments capable of peering deeper into space than ever before. The first confirmed discovery of an exoplanet orbiting a sun-like star came in 1995. This monumental finding was made by astronomers Michel Mayor and Didier Queloz, who detected a planet orbiting the star 51 Pegasi. This exoplanet, named 51 Pegasi b, was a gas giant similar in size to Jupiter but much closer to its star. This groundbreaking discovery revolutionized our understanding of the universe. It proved that planets could exist around other stars, opening up a new field of study in astronomy. The implications were profound, suggesting that our solar system was not unique and that there could be countless other worlds waiting to be discovered. Suddenly, we weren't alone in our little corner of the galaxy. The discovery of 51 Pegasi b hinted at the vastness of the universe and the potential for other habitable planets. It sparked the imagination of scientists and the public alike, fueling a renewed interest in space exploration and the search for extraterrestrial life. We had found another solar system, and with it the possibility of countless others. The realization that there could be billions of planets in our galaxy alone was both humbling and exhilarating. Each new discovery brought us closer to understanding the true nature of the cosmos and our place within it. The discovery of 51 Pegasi b, as this first exoplanet was called, ignited a firestorm of scientific inquiry. Researchers began developing new methods and technologies to detect and study these distant worlds. The hunt for exoplanets became a global effort, with observatories and space telescopes dedicated to the search. Astronomers around the world turned their telescopes to the stars, eager to find more of these distant worlds. They employed techniques such as the transit method, which measures the dimming of a star's light as a planet passes in front of it, and the radial velocity method, which detects the wobble of a star caused by the gravitational pull of an orbiting planet. The hunt for exoplanets had begun in earnest. With each new discovery, our understanding of the universe grew. Scientists analyzed the data, searching for patterns and clues about the formation and evolution of planetary systems. They sought to answer fundamental questions about the origins of life and the potential for habitable worlds beyond our own. And what they found was astonishing. The diversity of exoplanets was far greater than anyone had anticipated. From scorching hot gas giants to frozen ice worlds, the variety of planets was staggering. Each new discovery challenged our assumptions and expanded our knowledge of the cosmos. Exoplanets come in all shapes and sizes. Some are so close to their stars that their surfaces are molten, while others are so far away that they are shrouded in ice. There are planets with thick atmospheres of hydrogen and helium, and others with rocky surfaces and thin atmospheres. Some are gas giants larger than Jupiter with swirling clouds of gas and powerful storms. These massive planets often have multiple moons, creating miniature solar systems of their own, while others are rocky worlds like Earth. These terrestrial planets are of particular interest to scientists because they have the potential to support life. By studying their atmospheres and surface conditions, researchers hope to find clues about the possibility of life beyond our planet. Some orbit their stars closely, completing an orbit in just a few days. These hot Jupiters are often tidally locked, with one side perpetually facing their star and the other in constant darkness, while others take centuries to make a single trip around their sun. These distant exoplanets, often found in the outer reaches of their star systems, challenge our understanding of planetary formation and migration. The diversity of exoplanets is staggering, and it has challenged our assumptions about how planetary systems form and evolve. Each new discovery adds a piece to the puzzle, bringing us closer to understanding the complex and dynamic nature of the universe. The hunt for new worlds continues, driven by our innate curiosity and the desire to explore the unknown. The early days of exoplanet hunting were marked by a series of remarkable discoveries. These discoveries not only expanded our understanding of the cosmos, but also ignited a sense of wonder and curiosity about the universe beyond our solar system. Astronomers used a variety of techniques to detect these distant worlds, each with its own strengths and limitations. From ground-based observatories to space telescopes, the quest to find exoplanets has been a journey of innovation and perseverance. One of the most successful early methods was the radial velocity method, also known as the Doppler spectroscopy method. This technique has been instrumental in identifying many exoplanets, providing a wealth of data about their masses and orbits. This technique relies on the fact that a star and its planets orbit around a common center of mass. As the planet moves, it exerts a gravitational pull on the star, causing it to move in a small orbit or wobble. As a planet orbits its star, it causes the star to wobble slightly. This wobble, though minuscule, can be detected by observing the changes in the star's light spectrum. This wobble is incredibly small, but it's enough to be detected by sensitive instruments on Earth. These instruments measure the star's light spectrum, looking for shifts that indicate the presence of an orbiting planet. By analyzing the spectrum of light from a star, astronomers can detect these tiny wobbles and infer the presence of an orbiting planet. This method has been particularly effective in finding large planets that are close to their stars. Another successful method is the transit method, which looks for the slight dimming of a star's light as a planet passes in front of it. This method has revolutionized our ability to find and study exoplanets. This method is particularly good at finding planets that orbit their stars closely, as these planets transit more frequently and produce more noticeable dips in the star's light. The transit method has allowed us to discover thousands of exoplanets, many of which are in the habitable zones of their stars. These early discoveries, while groundbreaking, were just the tip of the iceberg. They opened the door to a new era of astronomy, where the search for exoplanets became a central focus of scientific research. They proved that exoplanets exist and that they are surprisingly common. This realization has profound implications for our understanding of the universe and our place within it. But they also raised more questions than they answered. What are these exoplanets like? Are they similar to the planets in our solar system, or do they have entirely different characteristics? What are these exoplanets like? Are they rocky, like Earth, or gas giants like Jupiter? Do they have atmospheres, and if so, what are they composed of? Could any of them support life? This question drives much of the current research in exoplanet science. Scientists are looking for signs of habitability, such as the presence of water, suitable temperatures, and the right chemical conditions. And how do we get there? The dream of interstellar travel, once the realm of science fiction, is now a topic of serious scientific inquiry. Researchers are exploring advanced propulsion technologies and the challenges of long-duration space missions. The journey to understand and explore exoplanets is just beginning. With each new discovery, we come closer to answering some of the most profound questions about our universe and our place in it. As we continue to open our eyes to the universe's secrets, we are reminded of the boundless possibilities that lie ahead. The search for exoplanets is not just about finding new worlds, it's about understanding the fundamental nature of our existence and the potential for life beyond Earth. Section 4. A Telescope Revolution, Unveiling Hidden Worlds. The search for exoplanets has driven a revolution in telescope technology. To find these faint, distant worlds, astronomers need increasingly powerful instruments capable of detecting the subtlest of signals. Ground-based telescopes have been upgraded with adaptive optics systems that compensate for the blurring effects of Earth's atmosphere. These systems use deformable mirrors to correct for atmospheric distortions, allowing astronomers to obtain sharper images of distant stars and their planets. Space-based telescopes such as the Kepler Space Telescope and the Transiting Exoplanet Survey Satellite, or TESS, have taken the search for exoplanets to new heights. Free from the limitations of Earth's atmosphere, these telescopes can observe stars continuously for years at a time, providing an unprecedented view of the cosmos. The James Webb Space Telescope, launched in 2021, promises to revolutionize our understanding of exoplanets even further. With its advanced instruments and unparalleled sensitivity, the James Webb Space Telescope will be able to study the atmospheres of exoplanets, searching for signs of water vapor, methane, and other molecules that could indicate the presence of life. Section 5. Reaching for the Stars, the Future of Space Travel. The discovery of exoplanets has ignited our imaginations and fueled our dreams of interstellar travel. But the challenges of reaching these distant worlds are immense. The distances involved are staggering. The nearest star system to our own, Proxima Centauri, is over 4 light-years away. Even if we could travel at the speed of light, it would still take us over 4 years to get there. And the speed of light, as far as we know, is an unbreakable barrier. Traditional chemical rockets, while powerful, are simply too slow and inefficient for interstellar travel. To reach the stars, we need to develop new propulsion systems that can achieve speeds approaching the speed of light. Some of the concepts being explored include fusion propulsion, antimatter propulsion, and even warp drives, which would warp space-time itself to allow for faster-than-light travel. While these technologies are still in their infancy, the very fact that we are considering them is a testament to the power